Okay, this is Unit 2, Section 2.6, our special right triangles, Day 2. We're going to look at 30, 60, 90. This will wrap up our unit. We will talk about what a special right triangle review, and gateway looks like, as well as what we're going to do for this unit review and test. So our goal today is to be able to recognize the second special right triangle pattern. So we'll have two different special right triangles, and these are big ideas that we want to make sure that we have practiced and implemented, and something we're going to use as we go through this rest of this year. And it's something that our Algebra 2 teachers have really stressed an importance for. And so we're going to use this 30, 60, 90 triangle pattern to find the side lengths again. And so where last time we talked about the 45, 45, 90, that came from part of a square here, where we then had our 45, 45, 90. Here's our 90. That split this, giving us these two sides that were the same, and this side that was multiplied by radical 2. The second pattern comes from a special right triangle, and it's from a isosceles triangle here. So if I took an isosceles triangle and split it down the middle, okay, an isosceles triangle, and actually this would be an equilateral triangle, where each one of these is 60, 60, and up here with 60, but it gets divided in half when I draw in this line. The other thing is, because this is equilateral, okay, it means all the sides are the same. So these two sides are the same, similar to how we had all of these sides the same because it was a square. These two sides are the same. So when I split this in half here, not only do I get my 90 degrees here, but I've also cut this as half the side length. So something that we look at is that if this is x and this is x, okay, well, the whole side length together is 2x's from here to here, which means this length is 2x. Okay, so then the last thing that we're missing is this side length here of our 30, 60, 90. So if I knew this was 10, I could say, oh, 2 times 10, this would be 20. If I knew this was 5, I could say, oh, 2 times 5, this is 10. Same idea, if I knew this was 30, 2 times 30, I could say, oh, this side is 60. But what about the third side of our triangle? This comes from Pythagorean Theorem. And so if we looked at, okay, maybe that's a y now. A y squared plus x squared equals that 2x squared. That's across from 90, whatever this is. There's a pattern here that we could find if we solved for y. And so what it ends up being is, if this way we multiply by 2, this direction we multiply by radical 3. That's the pattern. On this one, these were the same, and this was multiplied by radical 2. So we have a pattern here because of that split, that every time we take an equilateral triangle and split it, it becomes a 30, 60, 90, where the hypotenuse is 2 times that short side. So let's look at this more kind of formally here. So we have a shorter leg, a longer leg, and our hypotenuse when we have a 30, 60, 90. The 45, 45, 90 had 2 legs that were the same and the hypotenuse. Note, the shorter leg is always opposite the 30-degree angle, and the longer leg is always across from or opposite the 60-degree angle, just like the hypotenuse is always across from the 90-degree angle. So our shorter leg is going to be equal x. And so that's where we kind of just say, okay, this is our x value here. And when we look at it for x, this is going to be like our starting point. So I put the shorter leg here is x. How do I get the longer leg? I'm going to take short times radical 3. So that's equal to x, our short leg, times radical 3. And that's where this one goes here. The hypotenuse is short So our short leg times 2. So I multiply this one by 2 to get here. And that's where I would get the 2x here. And so this pattern here, we have a short side, hypotenuse, and our longer side here. Multiply by radical 3 to get the longer leg, multiply by 2 to get the hypotenuse. Notice the 30-degree angle, we're not going around this one. There's no relation for us to go through the 30-degree angle from this longer leg to the hypotenuse. So I always put an X, telling myself that I'm not going to go that way. If I need to go backwards, I'm going to do the opposite operation. If I know the hypotenuse and I need to go this way, I'm going to divide by just 2. And then if I need to multiply, by 3. If I go the other way, divide and then multiply. So this is the pattern we have here. It's x radical 3, and 2x for the 90. So let's look at a chart to put this together. We have short leg x times radical 3, 2 times x. So if I'm given the short leg, okay, that's our short leg, where we have x, we multiply by 2 to find the hypotenuse, which is 2x. We multiply by radical 3 to find the long leg, which is our x radical 3. So if I have the short leg, I'm going to multiply by radical 3 to find the long leg. And since I can't simplify that, that's my long leg. The hypotenuse, I'm going to take the short leg, which is 6, times 2, which is 12. So if I know the short, I'm going to multiply by 2 to go to the hypotenuse, multiply by radical 3 to go to the long leg. Now if I know the hypotenuse is 20, that's where I'm starting here. So to go backwards to the short leg, I'm going to take our hypotenuse and divide by 2 and simplify. Once I know the short leg, to go to the long leg, I'm going to multiply by radical 3. Okay, similar idea on long leg now. If I know the long leg, I'm going to not multiply, I'm going backwards. I'm getting smaller, so I'm going to divide 4 radical 3, that long leg, by the radical 3 to take me back to short, which gets me back to 4. Once I'm at the short leg, I'm going to multiply by 2. 4 times 2 gets me 8 here. All right, so these three kind of look like the pattern where I've given us a short leg, a hypotenuse, and a long leg, where they kind of fill in that x times radical 3, x times 2. This one, it's going to follow the same pattern. It's our short leg. And really, even though our chart goes long leg, hypotenuse, it doesn't matter which one we're finding first because both of them use short leg. So if I wanted to find the long leg, I'm going to take short and multiply by radical 3. So when I do this, in my calculator, I get 2 radical 3 times radical 3, which tells me is 6. On the hypotenuse, I'm going to take my short leg, 2 radical 3, and multiply by 2. Okay, the only thing I can combine here are the numbers out front, so I get 4 radical 3. So when we're doing this, the pattern is the same. Multiply by radical 3, multiply by radical 3, multiply by radical 3, multiply by radical 3. If you're going backwards, we're dividing something back. Divide by 2, divide by 2, divide by 2, divide by 2 gets you backwards. Multiplication makes something larger. The division in this case will make something smaller. All right, so if I start with long leg and I want to go back to short, okay, I'm going to go 8 divided by radical 3 and put that in my calculator and I get 8 radical 3 over 3. Take short leg and multiply by 2 to get to the hypotenuse. So I'm going to multiply by 2, and when I do that, I get 16 radical 3 over 3 as my final answer. Same idea here. Given the long leg, I'm going to first go backwards and find the short leg. So 27 divided by radical 3, and I get 9 radical 3. Once I have short leg, I can multiply to get bigger for the hypotenuse, and I get 18 radical 3. On this one, we have 8 radical 6, which is our hypotenuse. I want to divide by 2 to get back to the short leg. So 8 radical 6 divided by 2 is 4 radical 6. Once I have short leg, I multiply by radical 3. to get the long leg. So here I would get radical 18, so I would get 12 radical 2 here. Again, put this in your calculator and make sure that we're keeping it as a radical and not using our decimal approximation. So right now we want to leave it in the radicals. All right, short leg, if I have 18, I'm going to multiply by radical 3, and that would stay 18 radical 3. And for hypotenuse, I multiply by 2, and that gets me my 36. So the pattern here that we want to remember is that it's all about the short leg. We want to make sure that everything goes back to short leg. If we're going from long to hypotenuse, we're doing something wrong. Never did I go from 6 to 4 radical 3 or 4 radical 3 to 8. It's all about this column here. And okay, if I'm given it, I'm multiplying to get bigger. If I'm not given it, I have to divide to go backwards. But never did I go between these two columns. So let's look at a couple examples given the triangle. Where now, instead of a chart, it says find all the missing side lengths given the picture. So again, wherever there's this 30, I kind of cross out. I'm not going to go around this way. From short to hypotenuse, it's multiply by 2. Short to long leg, it's multiply by radical 3. So as long as I can identify the short leg, I should be able to find y. 5 times 2 is 10. And x, which is 5 times radical 3, which stays 5 radical 3. Okay, here's my 30 degrees, so I kind of mark it out, and look, this is my x. So going this way, I'm going to multiply by 2 because that's the hypotenuse. This side, I'm going to multiply by radical 3 because this is the long leg. So to get x, 14 times 2 is 28. To get y, 14 times radical 3 is 14 radical 3. And those are my two answers. On number 3, here's my 30, so I kind of scribble it out, remembering I'm not going to go around that way. And now I have x, so I'm going to multiply by radical 3 to get the long leg, and I have x, I'm going to multiply by 2 to get to the hypotenuse. Notice this time my x is unknown, so I can't take x times 2 to get 32. I need to go backwards using what I do know. So 32 got there by taking times 2. So going backwards, divide by 2. 32 divided by 2 is 16. And once I have 16 for the short leg, I can multiply it by radical 3 to get y. Those are my two side lengths. Similar idea here. Here's 60, which means this is our 30. Cross it out. If I take this, here's my long leg. Again, it's across from the 60, so I multiply by radical 3. Going to hypotenuse, this is times 2. So again, it's across from 90 times 2. If I go backwards using the side I know to find y, again, I'm not going to go around this way. I'm going to go backwards against my rule. So times 2 becomes divide by 2 going the other way. So y will end up being 23. And once I have 23 for my short leg, x becomes 23 times radical 3. And there's my answer. Our last two, now we're given the long leg. So in this case, I have short leg here, so I'm not going to go around this way. I have times radical 3 here and times 2 here. So to undo times radical 3 to find x, I'm going to take 15 radical 3 and divide by radical 3. The radical 3's cancel. On our calculator, we get 15. And once I know the short leg is 15, I can multiply by 2 to find the hypotenuse. So I get y equals 30 and x equals 15. Whoops. Kind of drew through my 1 there. And on our last one, here's long leg. Again, I can't go to hypotenuse, so I'm not going to go around this way. My short leg got there by doing times radical 3. My hypotenuse would get there by times 2 from the short leg. So this is how I do those patterns so that I can stay organized. If I'm going against my arrow to find y, I need to divide by radical 3 and simplify on my calculator. So in this case, I would get 2 radical 3 for y. And then if I simplified this, once this is 2 radical 3, multiply by 2 to find x. So if I multiply by 2, I get 4 radical 3 for x. So if we're practicing these patterns, we want to make sure that we understand how we're coming up with them and how to manipulate. Whether I'm given the short side, the long side, or the hypotenuse, I should be able to find all the sides. So one of the things that makes these special is that when we do Pythagorean theorem, okay, Pythagorean theorem, you have to know two sides. Then you can find other side. If I have a 45, 45, 90, I can use one side to find two sides. And that's what makes these the special right triangles, is that because we know some about their angles, now we can do this idea of knowing one side helps us find the two other sides. So while this is still useful, and if I know two sides, I might just go straight to Pythagorean theorem. But if I see that it's one of these special cases, then I could use that case to follow the x times radical 2 and the x radical 3 2x pattern. When we take tests or quizzes, this will be provided for you in this format so you can see the pattern, but you have to know how to apply it. So kind of keep that in mind as you're doing your practice. If you find yourself, coming up with a way that you're doing it specifically, make sure that you understand how you're doing it so that you can replicate that later. If you have any questions, let me know, and have a good day.